do something about what you have done so far. And because this time the retrospective is not like a normal retrospective, because most of the team haven't done much. So you will start working from now. So what do we expect from next time, that we are going to discuss a little bit about, and then you can tell about what you have done so far, because I figured that you already know your team members from, I think, last week, starting of last week, and you might have done something, or might have contacted the product owner, or might have planned something. So what's the progress so far, you can tell afterwards. So last time when we discussed this Scrum, we discussed that there are basically 4 types of meetings there. We do the sprint planning, we do daily scrums, and then at the end of the sprint, we do sprint review and sprint retrospective. And those 2 things you are supposed to do during the seminar. Of course, you can plan a little bit before, but mainly those 2 at the end of every sprint, we expect you to do during the seminars. So the first thing is you will be giving the demo of the increment from next time. And you will be checking whether the stories you have planned for that particular sprint, are you covering all those stories from the solution of the increment you are presenting to us. And you are going to focus on basically the functional requirements, because most of the time the product owners, the users basically focus on the functional requirement. That doesn't mean that you will not be considering the non-functional requirements, but that will be with your team and with the product owner, but not here. And then we will have the sprint retrospective, and your presentations from next seminar is going to answer these questions, apart from presenting the demo. What did we do well in the sprint? What didn't go according to our plan? What did we do wrong? And is there something we can do differently to improve the our outcome from the next sprint? And the answer of the last question may trigger one of these. Maybe you need to change the roles or the responsibilities. Maybe something about the meeting schedule, or maybe you couldn't communicate very well. So maybe you can add more channels so that you can communicate better. Or maybe some new routines in the development process to improve your next sprint. So already we have, these are the project basically, and I suppose there are members of every project team present here. So shall we start from the first one, a system to keep track of climbing accidents? Who are the team members? Can you please, okay. So can you just tell us something about what you have done so far?
Come on up to the front. At least one of you, we want to see you standing together. Good.
Yeah.
Thank you.
Well, we written a few emails to each of us, and this just make some hints or notes or proposals to what our group name will be and what our roles are. Joachim talked with Rune, I think, about the meeting. And we haven't set a time yet. That's what we are discussing today when the meeting, and what then we go deeper into the details, what the project will be, which language, and all this kind of stuff.
Okay. I suppose there is one remote student in your team.
Yes.
Are you in touch with him or her?
I believe he's at least answered, or has at least been in the email conversation.
Okay, so he's aware of whatever is going on.
Yes, should be.
But I could say that what I think, I think that Windows stack because it's a Windows app. With the ASX scripts and everything. That might be a challenge. If you can get them running, that will at least give you a feeling for the current implicit. Another was writing an email yesterday, I don't know if that was communicated to the whole group. The one in the planning federation board who is responsible for security and excellence. He is very willing to communicate directly with the needs and plans are. So that could be liaison person in between, but it might be better to establish contact directly with you right away and what the challenges are.
Okay. Next team. Structured testing educational tools. So can you tell a little bit about what you have done so far with the product domain? Did you plan something?
Yeah, we met as a group and discussed some things, and then we contacted our project owner, Jika, and got some more information about the project. Yeah, for the next sprint, we're planning on agreeing on what tools we are going to use and what language we are going to do the project in. And we also need to, there's some specific test examples that you're going to provide us with. So we'll, yeah, learn that and figure out a way to present it in the application.
Yeah, and also we have a second project owner for this project.
Mm-hmm.
So we are also planning to contact.
Yes, that is important, just like what Rumi said, because she is the one who is going to use this.
Yeah.
Yeah. So I'll provide you her contact address and also the examples. Basically, she is going to provide whatever is needed. Yeah. Thank you. The third team.
Yeah, so we've basically met up over a Discord channel and got in contact with all the team members, seeing as we also have a remote student. We have agreed on roles at least for the first sprint, and we're planning a meeting with the project owner Simon today. So the plan is currently to take that meeting and then actually continue to plan. But we're finished with all the group rules and group things and all the other stuff. And what language and environment we'll be using, I think it's better for us to decide that after we've had the talk with the project owner.
The last team.
So Benjamin is in contact with Mariusz, and we will set up the meeting. After the meeting, we will be talking about the technology stack and what we can do, because we need to find more requirements and understanding of what we actually need to do, and also what the students already have done. Mm-hmm. And we had a small meeting when there was a lunch, when we very quickly discussed and say hello to us, but we haven't been there. But then now we got a channel on Facebook, via Messenger, so we are all in contact.
Can I say something?
Yeah, sure.
So, just for you, it seems from what you're saying about the plans, it seems like you are planning for spending 2 more weeks on planning the project, which is, if you have a 4-person group, you already spend 120 hours. I don't know if you do the time recording, but you should.
because if you were when you start to estimate project, you need to know how much you can produce. Another way to know that is to actually keep records of it. So I suggest that you record what you do time-wise. So each of the 4-person teams has spent 120 hours. And if you spend another 120 hours and not get started, but just thinking about how and what tools, then we're going to be to a very slow start. So I would think that all projects should plan for something to demonstrate already next time. That's probably what you're going to say already.
Yeah.
But
Yeah.
keep in mind, the meter is running.
Yeah.
120 hours per team, 4-person team per 2-week sprint. So we should like to see some actual results, not just plans.
Yeah, from the
Sorry
next
for being
seminar.
grumpy, but I think that.
Okay.
It's better to get grumpy early
Yeah.
than
Yeah.
get grumpy late and just fail people.
Yeah.
Grumpy while they can still do something about it.
Okay. Then it's yours.
Right, okay. It has to be on the other side. I forgot my main device.
That's right.
You're on. I'm on. Yep. Yeah. Oh. Right, I was expecting to have a little bit more time. So, also on the Confluence, you should see under Spaces, like Computer Science Project, Seminar 2, which is today. You've all seen that? Right. So, under Seminar 2, I gave, which is what you guys are doing here as speakers. And then I'm responsible for these two things. And I gave you some links to web resources discussing those. And we're going to talk more about version control systems and code reviews now. So as I asked earlier, I'll ask again because we filled up the class. How many of you have used a version control system already? So who has never used a version control system? No SVN, no Git, no way of controlling versions. Okay, so everyone's used at least one. Okay. How many of you have used smart commits? 1, 2, 5. Okay, so a small section of the class, partly because I probably forced them to during their bachelor semester to use smart commits, have used smart commits. So one of the things we're going to go deeper into today is version control and moving beyond just saving code to a shared repository, but actually thinking about the way we document that process and the way we write code reviews. So, and do code reviews. So if I click and present here. Right, so apparently it doesn't want to start on my screen. Microsoft PowerPoint has stopped working. It's restarting. Yay. Let's try that again. Okay, it didn't like him to set up a secondary screen. Okay, so we're going to talk code control and semantic commits, which is the step beyond straight smart commits. Okay, so we're going to talk about here around Git and version control and moving on to smart commits and the difference between sort of temporal commits and semantic commits and automating processes continuous integration, testing, which is automation and different types of testing. We'll talk a little bit about, and the this is the idea we're going to cover in the first half, right? So I'm assuming that all of you understand what a commit message is in Git. So we have a bunch of bases that we're going to work from. Now I'm also going to switch into my code, my code, and start showing you how I do this with the projects I work with, and we're going to show you how things are integrated, right? So I'm not going to be constantly just up here and talking. It'll also be demonstration. So I've asked you, are you familiar with Git? So who has never used Git as a distributed version control system? So you haven't used Git. Anyone else hasn't used Git? Okay. So have you used Subversion and SVN? Okay. So then, right. So we're going to have a catch up on that. And so this is going to be quite a change for coding for you. But so one is we're going to have to assume that you have some familiarity with Git, that there are issues that you're trying to solve, right? So you've got a code base, you want to solve some problem, so you've got some issues. That recording information at the time it happens is better than trying to think back and reflect over it later to try and remember what happened. Right? So that's kind of the basis that logging while you do something is better. That there is some requirement to log your process. Right? So if nobody cares what you do or when you do it, then a whole bunch of this version control, issue tracking information is irrelevant because nobody cares. You don't need to do it, right? So as a basis for why you're doing this, somebody cares. Somebody's going to look at this log and care about what you did. Now, in this course, it's us. In real business, you will have a combination of potentially a client who's paying you to do things, and you have to document what you've done. We have an EU project, and we have to log hours for the EU to pay us. If we don't log those hours, they don't pay us. So we have to care. And internally, if you are going to debug and maintain code, having good logs, having a good background of why something was done, helps you maintain it and debug it in the future, right? So these are kind of some of the basis of assumptions that I'm making, that you care about these things, that someone's going to read it, and that you have a basic familiarity with Git. Now, as I said, I can go very quickly over Git. So Git has a kind of different model of version control to Subversion. And I think, unfortunately, most of the ways that we deal with Git at undergraduate courses are a bit like when people talk about Newtonian physics versus Einsteinian physics, right? So there's a simple way of understanding Git, which is just, there's like, you're updating the file. Yay, it's updated. That's great. How does it merge? Well, it just does it magically underneath. It just happens. And merging is okay. And when it fails, you just do it manually and you fix it, and then it's okay, right? We won't think about how it actually creates that long history and how it intersperses things and how it deals with multiple branches. No, we won't think about that. We'll just assume that it's doing it right, okay? So that isn't quite how Git works. So there used to be like centralized version control, right? And so there's still a debate out there about which is better. Should you have a single centralized repository for your code, which is the truth? Or do you have every person having a full repository of the entire project on their own machine? Right? So I know for some military contractors, they required to have a single centralized repository because they didn't want any one contractor to have the full code set. Right? So what you do is you have your code in one big repo, and then you carve off this contractor will have access to this part of the repo, this contractor will have access to that part of the repo, this contractor has access to this part of the repo. So no one of your external contractors can rebuild the entire system because they only have limited access to the single repository. And when you build the repository, only you as the military can build the entire project. Everyone else can just build their part of it and reference the whole, right? So for some situations, having distributed versions where you have a whole code repository on someone else's machine is like not sensible, right? You don't want to do that because of the safety requirement. There's also the challenge of diversion, right? If every single one of you has a full copy of the repository, then I've got the standard database caching distributed database problem, right? How do I make sure every one of you is up to date with each other, right? Because if you don't actually have a centralized system where this is the ground truth and all of you are copies of it, because then I can just say, well, all of you have to get back to this state. Whereas if I distribute my code across all of you, and all of you are doing updates, who has the latest version? Or do you all have the latest version that are all different? And how do you decide when it's completely distributed? Who gets to decide what's the current state of the project? So what do you guys do when you have completely distributed solutions and you need to decide who has got the current update, the current version of the document or the code? What's your process? Do you have a process?
The way we ran it at work was basically that the master branch was the sort of true branch, and then no merge did that. So
the master
no one was actually sitting with the true copy of the repository. So they're sort of centralizing it this one branch.
So you centralize one branch, and you centralize it onto a place. So it's a shared repository somewhere. Yeah. Okay. So because technically with Git, of course, all of you have machines. If you opened up your network ports and you opened up a server on your machine, you can serve your version of your repository because everybody's got a full version of the repository, right? Which means if I want to get a copy from PMS, I can do a pull, right? I can pull PMS's code into my code. Or I can do a pull request to PMS where he can pull from my code into his code. There is symmetry. There is no special thing that is the special place in Git version control. What you see is the way most people use that is that they put the special, the Bitbucket repository, that's where the ground state is, right? But it's just one of the places that could be. I could copy that, and I could have my personal machine being the true state, right? And you guys would just connect to my IP address and ask for my version of the repository, and that would be the current ground truth. All right, so instead of thinking that there's something special about Bitbucket, right? It is just one of the repos. Right? Now, one of the things that's you can do with Git and scare people a little bit when they first don't understand this is that I could go in and delete all of your Bitbucket repos, and your project should be fine. Because if you had a recent pull of the Bitbucket repo, then you have the full repository on your machine. Right? And you just push it back up to the Bitbucket repo, and it's fully restored. Right? So it's not that you've got like a copy that's somehow less than what's on Bitbucket. It also means that if you're going to have repositories, you can have them on Bitbucket, you can have them on GitHub, you can have them all over the place, right? You then have the issue of how to keep them all up to date, right? And what your update flow process is. Now, how you manage your process for doing your version control is up to you as a group or up to the company that you work at. Will define a particular process. But if we look at Git, what it does is when you have a conflict on your updates, Git records change sets, right? Which are a hash, or it's a list of the changes that were made across the project from a previous state to this state. Right? Now that set of changes can be reordered so long as they don't influence other changes that were made. Right? So there's actually a set of, oh, you changed this file and I changed this file. Those are two different change sets. Doesn't matter which order they occur, so long as they don't interact with each other, then I could apply them in either order. Right? That becomes important when you start having merge conflicts and you start tracking back through the history of things and trying to work out, well, you, and you, and you, and you have all made changes. How do we merge all four of these things back into one so I can look at the ordering of those updates? When you make changes to code, and this is one of the shifts we make as we move into more advanced code work, is when you touch code, right? Once you're working in a professional environment, when you touch code for a reason, right? You're not just there to tinker, to potter around to play. It's one of the things that academics are terrible at, right? Academics generally will start coding and they'll just code up some stuff to see if it works, right? And they don't really have much of a plan. They're just doing it because, you know, they're experimenting, they're doing research. So they haven't got like a systematic approach. We're trying to teach you applied computer science, and so we're trying to teach you a more professional approach to this, which is when you make a change, when you do change your code, there should be a reason for that change. Those reasons should be tracked with issues, right? Because we create issues and then we attach code changes to those. And each issue has information about it. Now, in the last couple of years, both GitHub and Bitbucket have added issue trackers to them. So when you go to GitHub, if you go on GitHub and you look at something like the master's thesis, we have the, that's because Microsoft PowerPoint believes that everybody has a second screen in their video. Right, so we have a community of practice for computer science education, COP-CSE, and with COP-CSE/NTNU, that's my GitHub repo for our code that we're sharing under that project. And your master's theses you will write in LaTeX. Well, you don't have to, but if you're sensible, you'll use LaTeX. If you're not sensible, you'll try and do it in Word. But if you're sensible, you do it in LaTeX. This is the master's template for that, right? And because it's LaTeX code, I have it in a repo. And in here, you see that I have issues. Right? So when you create a GitHub repo, if you create a new repo, it'll ask you to enable an issue tracker. Right? So if you enable the issue tracker, you'll be able to see currently a bunch of issues that are active in that, some of which have been closed, some of which are still active. So I have 4 open issues and 2 closed issues, and each of these has a number associated with it. Right? That's my issue tracking. And so in this case, I have issue 8 is GNU plot integrated script. So I created that issue because I've updated the code. And if we go into that issue, if I can find my mouse pointer. Where is my mouse pointer? Ah, there it is. Right. Unfortunately, yeah. So if I go into this issue, Right. So here, I've actually had a commit message hash, corrected the code for creating the box graph from the same CVS file. So I've written a commit message, and that commit message has the number #8 in the commit message. Right. So when I made a change, I wrote a message. I added the number of the issue that was related to. Now, I did this the terribly stupid academic way, which is I fixed the problem and then I made the issue. Because I thought, oh, I've got an issue. I'll fix that. Ah, okay, I don't have an issue. Right, I'll go and I'll make the issue, which is number 8, and then I can commit to it. Right? That's the wrong way around, right? I should have done the, what does my product owner need? Okay, these are the issues my product owner has. Right, I'll work on those issues, right? But I'm the product owner myself of this particular project, which made separating my mind hard, right? And so that's why we actually give you a product owner separate from the group, because otherwise it's hard to remember to separate your brain and tell yourself, I want this, so I will do this as 2 separate processes.
The problem is that you didn't have sprint planning meetings with yourself.
I didn't have sprint planning meeting. I didn't have a stand up with myself where I had a backlog and a sprint planning meeting with myself in the shower. You probably could do a sprint planning meeting in the shower with yourself. And I suppose depending on your flat area, you could do it with. So, I'm not. And some people get creative in the shower, so it might be a good place to have a sprint meeting. But yeah, I didn't have that meeting, and so I didn't create my list of tasks and then choose which task to do and then allocate it. It was I need to do that, I just did it, right? And that's one of the problems when you've been used to working on your own, thinking of a problem and then immediately going and solving it, right? Because you've been in that creative, think of what I need to do and then start doing it mode. Not that okay, we as a team need to achieve a whole bunch of stuff, right? Unless you've got multiple personality disorder, which, that's okay. You are a team in your head, but you don't generally do it that way. And so you tend to get this problem of solving a problem and then going, oh, wait a minute, there's no issue related to that. Right? So, but to try and improve my process, what I did is I then went and created the issue, said what needed to be done, and then committed code to it. Right? It also means that when people look back at the repo, they're able to see what bits of code were committed for this issue, right? So when I go into the code of this, and actually, and this is a bit hard because, here we go. When I go back, if I have a look at the code in here, and go down, and I go into the included files, you can see here, most of these files were moved in for issue 6, right? Issue 6, so I can see why they were moved to where they are. And then down here, there's one, this one was the one that was touched by 8. So I can go, okay, that was the last thing that touched it. And if I go into structure, I can then do where's my blame button? You have the blame button here somewhere, don't I? So this is the code that was in, and for, okay, maybe it's over here. It's off screen. Blame, there it is. Blame. It used to be called CVS Annotate, right? But they found that all of the companies referred to it as blame, right? Because it annotated who committed what line of code. And so when your code no longer compiled and there was an error in the code, you'd say, right, who's to blame? You wouldn't say, how should I annotate that error? Who's to blame? So they decided, oh, well, if everybody calls it blame, we might as well call it blame. So it's now called blame. And it goes through and it puts this line of code, what was the latest commit to change that line of code? Which means when you're basically, this adds a way of doing commenting on lines of code, right? Instead of having to comment in the code itself, right? Which is usually a comment about the code, not about why it's there or how it came about or what issue it was trying to solve or why the client demanded this change, right? You usually don't write that into the code itself because the code doesn't care about how it came about, right? So like the code is more like a chessboard, right? You don't care how you got the pieces to where they are on a chessboard. You can look and go, well, that's the state of the game. But if you are wanting to discuss the project, i.e. the game of chess, you need to annotate the moves. You need to annotate the history of how you got to where you are. And so this is what this does, is it tells you for each of the lines of code how it came about, right? What was being solved at that time? Who was trying to solve it? So if you scroll down, most of this was just initial commits. There is 6, and it had some changes, and there's a 6, and there's a 6, and there's the 8. So the 8, 15 hours ago, seeing I was just updating this recently, does this code, right? So this is the code that was changed when I did issue 8. So now I don't have to annotate in comments in the code, like why this came about, what I was trying to solve, what were the issues. I can just go straight into this plain commit, and I can click, and because it's all linked up, I can, if I get my mouse pointer, making much harder to see it. I can just straight click in there, and it'll take me to that issue and give me what was the explanation and when it happened, right? Now, as issues get bigger, more complex, this is a useful history for when you're trying to update or manage or debug or work out when something broke or why it broke or how it changed. This kind of annotation of what's going on is very important, right? It allows you to do a bunch of things. Also, what that does is in LaTeX, you can get your graphs generated in Goofbot directly from CVS files. So you don't have to create the graph and then import it. You can actually do it while you're coding. So, which is kind of a nice feature, again, in this idea of automating processes. So I'm not having to manually create the graph and then import it into LaTeX. I'm automating directly from my comma-separated file into a graph output, right? And that's what we're trying to do when we look at version control systems, is we're trying to automate as much as we can about the process of analyzing code. So get change sets, which are all those little changes, and the way it can do that annotation is by using the change sets and working out what code was related to what changes, and do connect those to issues. Have any questions about issues? You've seen issue tracking? Have you used? So who has not used issue tracking before? 1, 2, a few have not used. So we will expect you at the, in this course to do issue tracking, but we're going to ramp that up and actually make it proper project issue tracking, because those issues are lightweight issues, right? And Bitbucket and GitHub both provide standard numbered issue tracking, right? And they're just straight issues. They don't have time allocated to them. They don't have a bunch of other, like, is this a bug? Is it a feature? Is it part of an epic? They don't have any other information. They're just base level commits. We are now going to move into Jira. All right, so I've given you Jira repositories. You've all access to your Jira repository. Who has not been able to get into Jira? I know I told 2 people probably. You guys haven't been able to log into Jira? Right, so I'll have to fix that both of you guys, right? And we'll fix that today because you all need to be able to get into Jira. So that idea of issue tracking, right? That simple, like issue number 8, where I just have a description of the issue, and when I make commit messages, they get connected. With larger projects, we start having structure around the issues we create. Right? So rather than just me saying, oh yeah, this is just whatever issue, and it could be anything from fix a spelling mistake could be an issue. To restructure the document to enable automated builds or something, right? So I could have like a massive task or a tiny wee task, and in the issue tracker that'll just be an issue, and that makes it very hard to understand, you know, how many issues are left to do. Right? It's like when you're cleaning the house, right? If you just say, you know, if one line is clean house and another line is take out the recycling. Okay. If I do one and my wife does one, have we done the same amount of work because we each did one issue? Probably not, right? Because cleaning the entire house versus taking the plastic from the bench to do it outside, those issue sizes are so different that just because they're one line in my issue tracking system, doesn't mean they're the same amount of work or that they involve the same number of subtasks or any of those sort of things, right? So once you go beyond just saying, oh, we just throw some issues out there, we need some structure. We also need to work out that, you know, it's a fair distribution, right? That, you know, it's not that, you know, one person does everything and the other person does one thing, and well, look, there's only one line in the issue. I did one issue, you did one issue. Hey, that's fine. Okay? Whenever you're kind of allocating tasks to people, you've got to work out what's fair and reasonable. I'm sure some of you have lived in flats, working out, you know, who gets to clean the toilet versus who does the vacuuming versus who cleans the kitchen. You've all been through those arguments? Yeah, that's a task allocation, right? And you've got to find some way of evenly distributing those. So in Jira, we have issues with structure, right? And they go from the smallest thing, which is a bug, which hopefully is a small issue. Hopefully. Sometimes bugs become massive. We have features, we have tasks to achieve, you can have improvements, stories, which are user stories, and epics. Now, I don't think in our base one we have improvement in your current Jira task list. We can add that if you want to, right? These are just the suggested names for structuring your issues. If you want to have like different names, you could call one of these Fred. Right? We have Fred issues, whatever those are. But they're just a name to help you structure the way you think about the issues you have. When you create the issue in one of these, you can also, it gets a tag, right? So if we look in Jira, and this is my game, so the game programming course this year, I'm using Jira to decide what lectures get done and when they get done. Right? And so what we do is I've created these as issues, and my mouse. There it is. So here I have a backlog of issues, and I have 4 and 11 are in my backlog currently, and there are in Sprint 2 I've got AI, and then in the backlog I have 2. So GP or GProg 17. That's the index for my particular Jira repository, Jira project. Right? So you guys will all have like a 3 or 4 letter name for the short name, and then an issue number. And each of these I've inserted in Jira as an issue, and now they're in my backlog. So when I'm in a sprint, I get to decide to move them from the backlog of things that need to be done into the thing I'm going to do this week. Now, as issues, if we click down here under issues, you'll see that I have a list of all the issues ordered by priority. Now, how big and how long an issue should take this is a negotiation with the team, right? Now, I'm the one fulfilling these, well, Mariusz and I, and most of these are kind of a 2-week long because they're lecture content, so we know how big they are. But when you're doing issues where you don't know how big they are, you have to have some way of allocating complexity to them, right? And a way of estimating how big they are. Now, for these issues, I've already estimated them at about a 1 lecture per issue size. And so you see that I've got, if I have a look at my current sprint, and if I go to my sprint board, so game design patterns and programming techniques I put into the sprint this week. But this game programming patterns 4 is actually, I already pre-broke it into 2 parts because I knew that I wouldn't, oh, did I just move that back? Wait, there we go. Oh, it's over here. Why is my...
The resolution.
The resolution is making it very hard to do anything. It doesn't expect it to be that close. Right, so in here, I've already done game design patterns programming. I also have a separate one, which is user interface, right? Because I knew how much I could cover in an hour, right? Or 2 hours of a lecture. So I had already broken it into 2 parts. Now I could have had subtasks, and perhaps I should have made a single category and then added 2 subtasks and done each subtask in a different time. But the idea here is that I have things to do in the sprint, things that are in progress. I then have in review, resolved, and done. Now, that is part of the flow that we've created for you, is that we have these levels of issues. You guys get to decide how to use these phrases, right? But there is a default assumption, right? That epics are the really big things, and you tend not to do an epic within a sprint, right? And an epic is more kind of across the whole project, the big categories of things you need to do. Within those, there are smaller things. When I create these tags, if I use this tag in my commit message in my code, it links my code, just like I showed you with my LaTeX code, from the commit into the Jira project, right? Because we link Jira with the repository you're using. Right now, if you guys are going to use Bitbucket, that's generally the easy one to do. But Jira in the latest 7.4 version, which we updated at the beginning of this year, of this semester, allows me to do Git integrate with GitLab and GitHub. So you can use any of those systems, and we can connect your repository to your Jira issue tracker. Okay, so time in issues. Okay, so you've got this idea that you're writing code, you're solving issues, we go and write a bunch of issues, we then have a bunch of tag numbers that we can refer to when we write code. How do we estimate how long a project is going to take? How many of you have heard of story points? Okay, so about half of you, a bit over half of you have heard of story points. Okay, so one of the challenges, so interestingly, when we did the dog food project, so one of the really, I think, almost unique things that we did as a department about 4 years ago, just when Mariusz arrived, which actually was kind of really useful for Mariusz to meet everyone, was we ran this stack across the lecturers to make sure we understood what was going on, right? And we did various exercises on estimating how long tasks would take. And one of the interesting things to see was we had must have been like 10 or 12 of the lecturers. And we were estimating how long a particular JavaScript web task would take. Okay? Now, I estimated, looked through the task, did some subtasks, and estimated about 4 hours, 4 to 5 hours, a half day, right, basically. Right? Mariusz also looked at it and estimated independently of me about a half day's worth of work. And the other set of lecturers estimated as being between 12 and 14 hours. So 2 days of work. Okay? And so our estimates were quite a long way out for exactly the same tasks. Right? And so there's kind of various possibilities for this. It could be that Marish and I are massively optimistic, and so we just always get it wrong. Which, you know, there's a potential. It could be that the other group were massively pessimistic and always overestimate how long something's taking. It could be that because Marish and I had been coding web applications relatively recently, so that we were familiar with what needed to be done. And so for us, there was very little learning to be done. And so for what we looked at and went, I know how to do that already, I can just do it. Whereas people who weren't working on web apps looked at a web application going, well, I'd have to work out how to do that first. So that means I'm going to need an extra couple of hours in this task to work out how to do that, an extra couple of hours to work out how to do that. And then you add that up, and it's going to take you 2 days because you have to learn so much. Okay. So how big was that task? Is it a 4-hour task? Is it a half-day task or a 2-day task? Who was right? Depends on who's doing it. So is using hours necessarily your best way of measuring how big an issue is? Right? Because, you know, when I look at cleaning, like moving some stones in the garden, I can do the, well, you know, I can pick up like 8 of these, just carry them and drop them over there. If I get the kids to do it, it's going to take them like all day because they're kids. But and they refuse to do it anyway. But the amount of work required, the complexity of the task is independent to some extent of the person doing it, right? So there's a bunch of rocks that need to be moved from there to there, right? I can measure that, right? Doesn't matter who's trying to do it. That's a level of kind of task job to do. And then you can look at, well, if I had a digger, it'll take me 10 seconds. If I don't, then it'll take me an hour. And if I use the kids, it'll take me all day, right? So the hours are different to complexity. And so what we do is there is this idea of story points. And it's a measure of, and it's used as a measure of complexity, right? It says, okay, this is the amount of complexity required to do this task. How much complexity you add per hour to your code base, or like your velocity, your ability to work through complexity might be different. Certainly as a tech lead in a project, I might be able to look at that like 10 story points a day and go, well, you know, I can easily do 10 story points a day. And I might have just brought in a junior grad from university, say, well, he's probably going to do 1 story point a day. He's a grad, he's got lots to learn, he doesn't really understand the systems, he's not very efficient. So instead of allocating hours for a task, I allocate complexity points. And then we look at when you take on a task, you take on that amount of complexity and you work out how long it takes you to fulfill that part of the complexity. Right? You understand the difference there? So how many rocks can you move per hour? What we've got also, and you might have noticed in Jira, up here we have something called Agile Hooker. Have any of you done Agile Hooker? 1, 2, 3, 4, 5. Hey, so some of you have done Agile Hooker. Agile Hooker is the idea that when we're trying to estimate how big a task is, it can be difficult to just all agree immediately and say, oh, that's obviously a 2-point complexity activity. Okay? Now, I know, so you get the same kind of negotiation of complexity going on anytime you try and divvy up jobs, right? So when you're trying to divvy up the jobs in your flat, right? It's so is cleaning the toilet equivalent to cleaning the kitchen? Right? And do you measure that by the number of hours or some level of disgust in the activity? Right? So, and how do you trade those off, right? You say, okay, I'll do the vacuuming for a year if I never had to touch the toilet. So long as that's someone else's job, I'll do this job, right? I know it takes longer, but I'm happy doing it, right? So to some extent, the value people put on different activities varies, right? And so you have to work out a common agreement. So what they do in Agile Hooker is the idea is that you look at a task, each of you independently allocate a number of story points to it, right? You write that down on the card and you turn over the card, and everybody turns over the card to see if everybody agrees, right? And then you start negotiating and playing those levels of complexity. Now, one of the ways you can do this on a kind of deck of cards approach is that there are a whole bunch of tasks and you have a bunch of points to spend. And so you allocate those points to each of those tasks, right? And so you're kind of gambling on what you think is the hardest one, right? You look at that and go, oh, that's gonna be 10, that's only 2, that's only 3. So you write down you allocate all of the story points, the complexity you have to those tasks. You play them out, everybody plays them out. The cards that everyone agrees on, great, done, sweet, estimated. Right, move on. And the ones that you disagree on, you then start negotiating. Okay, so why do you think this is a 10.1 when I think it's a 3.1? What have I missed, or what have you added? Right. So you then kind of negotiate. You can have some discussion, and depending on how you're playing poker, you then go back to another round of everybody estimating and playing their cards. Right. Once you know the complexity of tasks and they're put in the backlog, you as a developer pick a task and go, right, okay, I'll take that 2 story point task. Oh, and there's a 10 story point task. I know I'm supposed to do about 20 points a week. So I need to take a 10, a 5, a 3, and a 2. Right? So I'll take those ones. Someone else goes, oh, I'm just going to do one task. I'll take the big 20-point task. Right? So although one person does one task the whole week, another person takes a whole bunch of tasks. You try and even it out. And because you've agreed beforehand how big those tasks are, everyone's happy that everyone's doing their job. Right? Because that's one of the challenges we have whenever we put groups together at university, is somebody thinks somebody else is not doing enough of the job. Right? I'm nearly at the point of suggesting that to my brother-in-law, because they have a fight over the dishes. Because my brother does the dishes, but his wife reminds him to do the dishes. Okay? So she considers that she's doing the managerial job of making sure the dishes get done, right? Because she's the one that has to tell him when to do them and keep an eye on it and make sure they go. Whereas he's the one that actually does the dishes, right? So in his mind, he's done 100% of doing the dishes because he did the dishes. In her mind, she's done like a third of the job at least by structuring and managing and organizing things. So now there's 130% of work done. And so there's now an argument over how he hasn't done the dishes, he's done the dishes. But she had to remind him to do the dishes. So, where is 100% work and who did the dishes, right? So if you agree beforehand and actually put in have a sprint meeting and everybody agrees what percentage doing the dishes is versus managing doing the dishes, then you can resolve some of those complaints, right? Now, they might not be uncommon complaints for you guys to experience in the future, particularly around organizing flats and things. It's like, how much work is a particular activity? We're going to try and get you to do it this way. And so in Jira, you can estimate on 0 points. You can estimate on hours. You generally log hours to your workload and story points to complexity, right? And that allows us, and the reason we do that is it allows us to work out something called velocity, which is how many story points you are processing per time you work. Right? So it's like, instead of kilometers per hour, story points per hour. As Bruna said, we're always going to estimate badly. So you will get the wrong estimates. What's time?
Quarter past 10.
Yep.
A comment here. I don't know if this is the right place, but one thing you need obviously is going to be to know the budget. How many hours do you have? And the issue tracker, as put up here, we just track the issues. Now, as a team, you need to spend hours on other activities as well. I don't know if you.
Yeah. So in terms of estimate and tracking the number of hours. If you go into your JIRA, what you'll see, and yes, we need this is in each of these issues. So if I double click on this issue, it's a major, it's a story, and it tracks, so updated, created, time tracking, right? So I've got a non-specified, but I've logged 3 hours to it, right? So I didn't specify how many hours I was going to do. But when I log my time, I've logged my time to this. Under estimated, if you put in estimates for your tasks, it will then give you what's called a burn down chart, where you have the amount of resources you've got and how many hours you estimate each of these tasks is going to take. And then as you do them, you can burn them down and match to see if your estimates and your reality of logging match up, right? And that's where this remaining. So estimated, when you first create an estimated, you'll get a remaining that's the same time, and then you'll put hours into that. So if we create a new issue, so I create an issue, and we create a make a task, and down here, priorities, labels, attached, issues, assignee, epic link. So here, these are kind of the fields that I can put in. Epic link, because epics are big, you can link tasks to them. And I can also put them in sprints. I can automatically assign who is supposed to do this. And I can look at, given that there's a task, I can associate it with other issues. Now you can see I've got a lot of potential issues that are associated with my install. So I've got the game programming issues, there's some C61s. There's the IPA. Who's IPA? Is that? No, that's one of the other groups. The IPA, which is sounds like beer. IG4, GAT 99. So these are students who have started putting in particular issues, right? So I get them from the whole, because I'm managing massive number of projects. I'll get a massive list here. Hopefully you guys don't get all of this as a massive list, I would assume. You guys hopefully don't.
But those I was also thinking of, in your projects, you may need someone to learn a toolkit, or you have the choice of 2 libraries, and someone needs to study and compare libraries. It's not productive in terms of producing any code. There's no commit to
associated with it. Yeah.
But if you don't put them on the Jira tool, you get the wrong impression of how much work is actually done. So when you look at the burn-down charts, I've seen before, look at the burn-down charts, it seems that you're working 10 hours. But then when we ask the students, so why just work 10 hours? Oh, we have to start this and that, and it doesn't show up because it was never estimated and it was never planned or didn't show up in the plans. So it means that the burn-down charts are going to be wrong. So even though the issue tracker is for issues of the software, I think in your case, you can use it as a general management tool, which all the activities you have, if someone needs to learn something, put it up and say how many hours you think they will need to manage this piece of software or learn something. And then when you look at the burn-down chart, you can see that, okay, you spent 130 hours, and a lot of it was on activities in selecting libraries and getting to learn stuff and setting up. But at least you can have a burn-down chart that shows that you reach your goals for the sprint.
Yeah, and so in Jira, basically, if you have work that isn't related to code, right, as Ruben said, in log work up here, right, so under the menu, there is just the log work where you can go and you can click log work and put in the time spent and automatically adjust estimates will reduce the amount of work, use existing estimate of 0 minutes or set to and reduce by, right? So I can go into here and I can just say, well, you know, I spent.
But that's loaded to an issue. So the first person needs to create the issue.
You need to create the issue, yes. So you need to create an issue and then you can manually log work to it, but you need to learn this tool, evaluate this framework, read these papers, right? So with Miriam, we're using Jira to kind of understand all the things she's got to do by the end of her thesis, And so we're looking at how much time she's allocating to writing particular papers, doing particular research. So she's not writing code, she's using it as a project management tool. Now, one of the decisions I made for all of you guys is I made you sprint boards. So I made you all with Scrum models, right? Jira also supports Kanban and project management, where it just gets rid of some of the features of having scrums and sprints and backlogs and things, right? It goes, it uses kind of a different approach. Okay, so we've been going for, you've been sitting for far too long now. We shall get up and walk around. I haven't finished this bit of the lecture, but we might as well take a break now. And when we come back, we'll talk more about estimates and we'll move into semantic commits and how you commit what you meant to change rather than just when you changed it. Okay, so go stand up, go and take a break, walk around. And if you think of any questions, come back and like ask me either now or when we get back. Bye, internet people. Wait for internet people to leave. Now.
On pulse?
How long the break will be?
I don't know, Simon, how many minutes you will?
About 10, 15-minute break, right?